Okay, this is the P4 paper from January 2024. It's question number 4, which is a differentiation question, and in particular, as we can see from part B, rates of change question. Let's have a read through of it. It says we've got this cone here with height 5, radius r, slant height L. Part A is easy, so let's just do that first of all. It says find an expression for L in terms of r. Well, looking at these three things here, I'm hoping that everybody can see this is just going to be Pythagoras, isn't it? So part A, we get that L squared is equal to 5 squared plus r squared, and they want L, so L is the square root of 25 plus r squared. So part A done. Part B says, given that the base radius is increasing at a constant rate of 3 centimeters per minute, so that's dr by dt, radius dr by dt, can we find the rate at which the surface area changes? So can we find ds by dt? And then it tells me that we'll be doing that when r is equal to 1.5, and also down here it tells me the formula for s. So part B, let's summarize what we know. We know that dr by dt is equal to 3, and we know that ds by dt is what I'm looking to try and work out. So looking at those then, ds by dr would be a useful thing to have in terms of dt, dt leaves me ds's and drs when I'm looking at it. So ds by dr is what I should be looking to try and find here, and we've got that s is equal to pi r squared plus pi rl. So because it's ds by dr, I know I need to get rid of that l there, and they've sort of led us into that, haven't they, anyway, with what they've done there. So they're trying to lead us through this question. So what I need to do with that formula is, before I can do anything else with it, let's just get rid of the L. So S is equal to pi r squared plus pi r, and then, not very nice, 25 plus r squared, square root of that, but we may as well write it as to the power of a half. If we're going to be differentiating, we need to be able to do something like that. Okay, so unusually within a rate of change question, the differentiation is actually going to take a little bit of time here. What I'm going to do with this part is call this a product and work out that one there. So remember, the differential of a product is equal to u dv by dx plus v du by dx. It's up to you how slowly you want to do this. They're not very nice, so it might be that over here you just say u is equal to pi r, so du by dr is equal to pi, and v is equal to 25 plus r squared to the power of a half. So dv by dr then is going to be, how do you differentiate that? You say, treat it like it's a power, so 25 plus r squared to the minus a half, okay, multiplied by the power, take one off the power, but then multiplied by the differential of what's in there. So multiplied by 2r. Now I'm going to tidy that up to be r 25 plus r squared. Handwriting is absolutely dreadful there. To the minus a half. So now when I'm doing my differential, I can say ds by dr, I'm going to differentiate all of this. Okay, so ds by dr, differentiating pi r squared up there, ds by dr will be 2 pi r plus, and then saying u dv by dx, v du by dx. Actually, if I'm being 100% accurate here, I should change all those x's to r's, shouldn't I? But nobody's going to worry about that when we're doing that. So it's u dv. So u dv is going to give me pi r, and then r 25 plus r squared. Sorry, there's something wrong with it. I can't write this today. To the minus a half. That's uv plus v du is going to be pi 25 plus r squared to the half. So when we're doing that, we can tidy it up a little bit if you want to. I'm going to call that 2 pi r. I'm just going to call this bit pi r squared. 25 plus r squared to the minus a half plus pi 25 plus r squared to the half there. And then when we're actually doing this, you can take pi out, you can do all sorts of things here. But really all I've got to do is substitute in. So I'm going to leave that like that. I'm now going to say, let's do the thing I was trying to work out, which is ds by dt. So ds by dt is ds by dr multiplied by dr by dt. So it's that bit that we've got up there, 2 pi r plus pi r squared 25 plus r squared to the minus a half plus pi 25 plus r squared to the half, yuck, all of that times dr by dt, and dr by dt is 3, okay? And what we've now got to do is the question said, can we find that when r equals 1.5? So ds by dt is going to be 3 lots of 2 pi 1.5 plus pi 1.5 squared times 25 plus 1.5 squared to the minus a half plus pi 25 plus 1.5 squared to the half. Not really a lot I can say about that. I can put in derivative values. You just got to go away and stick all that in now and make sure that you can do that. It is just substituting in. Apparently it comes to 81.5, and when it comes to 81.5, let's just have a look back. It does say to 1 decimal place, and I may as well put the units on of centimetres squared per minute there. But yeah, that last little bit about substituting in, good luck with that. That's just something you have to do on your own. Apart from that, the rest of it, relatively straightforward. Hopefully all of that makes sense.